All right, hello everybody. This video is to help you with the Serengeti simulation part 1. If you don't want to watch this video, you don't need to. You could do this entire thing by yourselves. But if you just want to watch and kind of complete it along with me, that's totally great too. In that case, I would open up the worksheet on one tab next to my video and then me on the video next to you. All right, so the first thing that I just want to show you really quickly is the simulation itself. And it's a pretty slow simulation on our Chromebooks. It goes a little bit faster on some of the more powerful computers. But let's take a look at what you can do on this simulation. So first of all, I'm just going to hit Setup Reset so you can get a sense of what it looks like. So there are 3 areas in our simulation. They represent the southern region of the Serengeti, the central region of the Serengeti, and the northern grasslands. They're all grasslands. Of the Serengeti. And then you have all kinds of things that you can change. You can change how many buffalo are going to be in the area. You can change whether or not there are fences present. You can change the grassland, how much is grass and how much is rock. You can change whether there are seasonal rains or not. We're not going to mess with any of that yet. We just need to see the simulation in action. So I'm going to go ahead and just hit go. You can see what it looks like with 10 buffalo. So we're watching 10 buffalo move around, and they're trapped by fences. So they're stuck in the central region. Notice in the northern region it's raining. And I'm giving them, a few minutes. And actually, I'll show you, we can even speed up the model, and I can bring it way up here to go at 100% speed, but it still takes a while. So we're going to let this simulation go to like time, 2000, 1500, something like that. It's only at time 300 something right now. So it takes, each time we do the simulation, it's about 5 minutes. But what you see here is a graph of what's happening to the buffalo. And I'm actually going to pause it because I don't want to spoil your graph. So that's what's been happening in this simulation, and we're only to time 500. So now let's take a look at your worksheet, and it says if you started with 50 buffalo, we started with 10. And when you just saw, that was with 10. If we started with 50 buffalo, and here's 50 buffalo right there on your graph, and you ran the model for a while, let's say just to time 1,000, that's fine. So twice as long as we just ran it. What do you predict the shape of the graph of population size versus time would look like? So do you think if we started with 50, do you think the population would increase? Do you think the population would decrease? Do you think the population would stay the same? It's just a guess. So you just go ahead and use a drawing and you show what you think would happen. I don't care. Maybe you thought it goes down or up. It doesn't matter. Nothing is wrong as long as you have a guess there. All right, so now let's take a look at what's actually going to happen here. So we've got it open. I'm going to go ahead and get everything set. So it says open a browser. I've got it open. It's on our assignment page. So if you want to open it yourselves, you can. It uses a lot of brain power from the Chromebook. So the Chromebook gets a little laggy when you use it. And it says, B, you should see this interface. We already did. You now have loaded the model and it's ready to run. Change the buffalo to add slider to 50. So let's make that. We can scooch that all the way up to 50. You can also just type it in 50. That works as well. Let's see what else it says. Press the setup reset button, press go pause. So there's nothing we need to do. It just says keep the model running until the time is between 1500 to 2000. So I'm going to go ahead and we're going to reset. So I've reset it. Oh, it's supposed to reset. There we go. We've reset it. Now we have 50 buffalo. They're trapped by the fences. They're in the center region. Let's see what happens. So I'm going to go ahead and hit go pause. Now it's going, and it's going full speed, and you see the different animals eating the grasses. That's what all the little green boxes are, is them eating grass, and so there's less and less grass. So we're actually seeing the population decline initially because we can assume there's not enough food, and some of them are starving. So the population's going down and down. We'll give it a few minutes to keep watching and to see what happens. Will the population come back again, or will they die off totally? So you could speed my video up. Maybe that's a good idea. Speed the video up until we get to the end. I'll just sit here quietly. You can speed up the video. what I see happening is that they're not really declining anymore. We don't see them disappearing. We don't see them totally all going extinct. They dropped down for a while, then they came back up, then they dropped down again. Now maybe they're coming back up again. Oh, a big increase there. Let's keep seeing. Let's keep watching. I think I'm going to go ahead and pause the video, and then I'll restart it once we get to the end so you don't just have to sit here listening to me. Okay, I'm back here. I've waited until the time 1500, so I want us to kind of focus in on this graph here to see what has happened during the time. So I waited all the way until time 1500. Ignore the wildebeest. We don't have any wildebeest in this simulation. So if I run my cursor over the numbers, we can see kind of what the numbers are. So we started at 50, and the numbers dropped pretty significantly. And then we started increasing again. We got into the upper 40s, and then we started going down. We're in the 30s, and then we came back up around 40 again. And we ended somewhere around 40. And so what we're seeing, and if we went even longer, we would see this fluctuation somewhere around 40, very roughly somewhere around 40. Okay, so let's go ahead and look at your diagram. This is what you're supposed to graph. Now, unfortunately, right here, I'm going to circle it on my computer here. Right here, it says 1,000. It should say 1,500. So go ahead and cross that out and write 1,500 instead so that we understand that it was 1,500 and not 1,000. And then go ahead and draw what this looks like. So I'll give you a moment to draw this graph. Gonna pause it while you draw it. Okay, one of the custodians was just here. So hopefully you've drawn this graph on the first one. So now we're gonna do it again. So it says, repeat steps D through H, changing the buffalo to add by either increasing or decreasing the buffalo. So we started with 50 buffalo this time. Why don't we start this time with, let's go with a bigger number. Let's try 75. Let's see what happens if we start with 75 buffalo. So let me go ahead and hit setup reset. It resets the whole thing, hopefully. I told you it goes really slow. It takes a lot of the computer's juice to be able to get this done. Okay, I'm going to pause my video because for some reason we're having a little delay here. Okay, sorry. It took my computer just kind of froze when I'm trying to record and trying to do this simulation at the same time. So I've reset it. This time I'm doing 75 buffalo. I'm going to go ahead and hit go pause. Even if it's not working instantly, I will pause my video and I will come back so that you can see the results of the 75. So I'll go ahead and pause my video right now. All right, everybody, I'm back and the second simulation is all done. Let's go ahead and take a look at the graph and see what happened. So this time, let's see if I can, I'm just going to try to move it up a little bit. Reset zoom. I don't know what I did there. There we go. All right, I was trying to get it to scroll up more center in your view there. That's the best I can do. All right, so what happened this time? Well, we started with 75 and they just bottomed out. They barely survived. We got down to 4 buffaloes at our lowest. Yep, we got down to 4 buffalo. But then they bounced back and they came back and they went over 50. Oh, but then they rebounded again and they went down to 28. And I'm going to guess that if we went to 2,000, which takes a long time, if we went to 2,000, they're going to kind of fluctuate again right around 40, which is what we saw last time. So I want you to keep that one in mind. So go ahead and draw this picture on your screen. So on your for your graph number 2, and again, get rid of it says time 1,000, so make that time 1,500. Excuse me. And then let me show you the graph again so that you can draw it. So draw that graph for your second graph. And then we'll go ahead and move on. I'm hoping you were able to draw that. You can pause me at any time that you need to. So let's go back and see what we need to do next. So it says using your graphs, the 2 that you just made, and these graphs, I'll show you them in just a second, of differing buffalo population sizes, make observations about any patterns that you see. Okay, so when we started with 50, we saw them drop and then fluctuate around 40. When we started at 75, we saw them really drop, but then come back again. Let's see what happens when we start with fewer or more. So I took some screenshots so that we didn't have to watch the simulation every time. So here's where we started with 10 buffalo. They didn't drop this time. They increased up, up, up above 50. Oh, and then they dropped. Oh, and look at that. They fluctuated around 40. Let's go back. We start with 25 buffalo. This time they drop a little, but not too much. And they go up to 50, and that's too much. And then they drop and they fluctuate around 40. Let's take a look. Starting with 50, we already did this one. Here they are fluctuating around 40. They get up to 50 again, but then they drop off. Here's them starting at 75. They drop, they go back up to 50, and then they fluctuate around 40. They never go back to 50 again. Here's starting with 100. We got all the way down to 2 animals. There were just 2 buffalo left. So they just totally dropped off. They're all starving. They're all dying. And then they rebound above 50, but then they start starving and dying again. And eventually they fluctuate back up to that 40. So what we want to do is type here, come on, there we go. We want you to come up with any observations and any patterns you see. So the number that we start with determines whether the population goes up or down initially, but all of the populations, no matter how many we started with, they fluctuated around 40. So I would say the words fluctuated around 40 are really important. So give me 2 sentences here that say something to the effect of, it doesn't matter how many we started with, we end up fluctuating around 40. We end up going up and down around 40. That's what we're trying. That's our observation. That's our pattern that we're seeing. Okay, let's move on. So now number 3 says, why do you think the population tended to return to a stable state of about 40 buffalo in many situations? And I'm hoping that you can figure this out on your own. But the answer would be that when there's too many buffalo, they run out of food and they starve. And when there's not enough buffalo, then there's so much food that they can start eating and reproducing, and their population increases until they run out of food, and then they starve, and then they increase and they starve. So it's all about how much food is available. So you need to write something like that. A couple sentences is always good. You don't need to write as much as I say. Give you a moment. Pause me. I'm just going to keep moving. So if I go too fast, just pause me, give yourself a chance to type, and then restart me. All right, question number 4. Sometimes if you start with 100 or even more buffalo, the entire population of buffalo will end up dying off. Why do you think this happens? Well, I think it's pretty clear. They ate all the food. There's no more food. And the food doesn't grow back fast enough to feed them when there's that many of them. The food keeps growing back, but slowly enough that they can't survive. So they eat all the food and it doesn't grow back fast enough. Pause if you need to. All right, conclusions. We're almost done with this one. Carrying capacity. This is a term you need to know and you're going to use in your summative. Carrying capacity is the number of individuals an environment can support. Carrying capacity depends on the resources available that are needed to support the population, like food, water, space, all those kinds of things, grass in this case. If a population goes above the carrying capacity, some organisms will die off, causing the population to decrease. And then it got cut off. The words got cut off here, but they don't matter. So take a look at the graph. Look at the blue line. The blue line represents what we think is the carrying capacity. So if you go across to the numbers, whatever this population is, this isn't for the buffalo, this is just a sample graph. But if you go across, you can see that the carrying capacity is around 1.5 million. The pink line represents a real population. And you see that population, they're reproducing. They go over the carrying capacity and they start to starve to death. And so their population, more of them start dying. Their population comes down below the carrying capacity. And now there's enough food because there's not very many of them. So they start eating well and reproducing, and their population comes back up. And you see it fluctuating around that carrying capacity. So that's what carrying capacity is, that fluctuation point. So number 5 says, how is the idea of carrying capacity related to the outcomes you observed in this model? So you can answer, and you're always welcome to use my words or your own words. You can say, okay, carrying capacity is the maximum number of living things that the environment can support. Organisms is the right word. It's the maximum number of living things that the environment can support. In our simulation, the carrying capacity was around 40 buffalo. In our simulation, the carrying capacity was around 40 buffalo. Okay, so just one last thing I'll mention, you guys. This simulation you're going to use for a summative project coming up. You're going to do one more practice here. It's called Serengeti Simulation 2, Part 2. And then you're going to do the summative Serengeti simulation after that. So just make sure you're paying attention. The word carrying capacity is important for the summative. All right, that's it. Hope you have a great day.